Very good.
How to prevent DNA?
DNA bases. And how to prevent the DNA function? Yeah, this one. You know, this is the DNA.
Yes.
They have the A, T, sorry, C, G. If they binds here, this bond will break. This bond will break. If this bond will break, no functions of the DNA. Sorry. Hello? This is the for a workshop. It's the workshop.
Take your time.
No, come on here. See, mitomycins. These mitomycins, they will not act by intercalating. They have another mode of actions. They have mode of actions by alkylating agents. Give me another what is
Marker.
another marker. Yes, they act as alkylating agents, not as intercalating agent. Because intercalating is the different. Alkylating is the different. Alkylating means alkylation. You know alkylation?
Yes.
Means alkyl group. Alkyl group. Now question is that where they undergoes alkylations? We'll see here. We'll see here. This is the mitomycin structure. This is the mitomycin structure. Mitomycin structure. Importantly, they have one ring, two groups, three rings, and four groups. Means they have importantly have four groups: amino group, quinoline ring, urethane group, and aziridine ring. Now, can you give me answer? What is this one?
Proba, cyclopropane.
Cyclopropane. What is this one?
Epoxide.
Our oxirane. Oxirane or epoxide. Good. What is this one?
Sulfoxide.
Thioetane. Thia. Sulfur. Oxygen. What is this one? Asa. Aziridine. See the blue color? See the blue color? Aziridine. They are the very biggest structure again, but only and only this aziridine is responsible for activity. If they have no aziridine in mitomycins, have no activity. Now see how this happens. This ring will open by a lot of process. By a lot, please don't know the process. What you know here, I will discuss after 2 minutes or 3 minutes. This is the aziridine. This aziridine ring will open, and finally, you know conjugation, single bond, double bond, single bond, double bond. See here. Single bond, double bond. Single bond, double bond. Single bond, double bond. You know conjugation? Now, honey, you give me answer. Please don't give anyone. This bond shift from here to here. What happens here? Positive or negative?
Negative.
What happens here?
Positive.
Anyone tell me, please?
No.
Positive.
Positive, negative.
Very good.
Yeah.
Oh.
This bond shift. This bond shift from here to here.
Yes. Okay.
It means here it will be positive, here will be negative. Now, again,
Increase the bond. Increase the bond. I will increase the bond. So how there is a negative will be?
bond will shift from one place to another place. Those bonds shift from your previous place, they will be positive centers, yani deficient center, yani poor center. And those bonds shift from a head side, this is called as rich center or negative center. Now, this positive center, see, this positive center. Now, you know the DNA has the negative center. Where?
I mean,
honey, please.
Huh?
Where?
Negative.
Huh?
And inside the base.
Base as well as?
I mean, in H2.
DNA have the negative center. Where? Base or backbone? Phosphate.
Phosphate.
Don't forget the class, please. Just recall the classes on phosphate. Have the PO4 minus. Have or no?
Yes.
Now this positive centers binds the negative centers of the
DNA.
DNA backbone. This is the one DNA backbone. Now see here, two DNA backbone. Two DNA backbone. Both DNA backbone.
Okay.
Both DNA backbone will binds with the mitomycin. With the mitomycins. And finally, this DNA will no action. No action. It means no another DNA synthesis, no RNA synthesis, no protein, no cells, no growth. They have the antimicrobial as well as anti-cancer. By this mitomycins, they prevent the action of the DNA.
It binds to the phosphate
Phosphate.
and they prevent everything.
Yeah, everything. By which bond? Anyone tell me? Yes.
Again,
Ionic bond. Ionic bond, negative to positive. Now, if I ask the questions here, they have the 4 groups. This is your questions in your exams. Like this way, they have the 4 groups: aziridine, urethane, quinolodine, and primary amine. Which of the following groups will open or they undergoes a lot of process and they form electrophilic center so that they have anti-cancer activity or antimicrobial activity. Only and only aziridine. Only and only aziridine.
Bioelectrophilic, which is positive.
Yeah. Electrophiles, E plus.
Class.
Or they are also called as cation. They are also called as carbonium ion. They are also called as electron deficient center.
So they bind to
Backbone.
And what's the benefit of other groups?
Huh.
Other groups.
What is the benefit of the other groups? See, they yes, yeah, they will intercalate. They are the newest theory. They are the newest theory. They have 2 modes of action. One is alkylating, another as intercalating. But already I discussed intercalating, so that I will not discuss intercalating.
And the action is due to the ionic bond, not the intercalating.
Both.
This time.
Yes. This is
what's happened to us?
aziridine, alkylating agents. The one undergoes alkylating agents.
we add them to identification.
Alkylating agents, alkyl group, because they have, see here, they have the positive center, they have the carbon alkyl group. You know methyl group,
Yes.
ethyl group. They have the carbon, like here CH4, loss of one hydrogen, CH3 plus na, methyl group na, alkyl group. Same as that of the whole group as alkyl group. Alkyl plus R plus. That's why they came in the category of alkylating, but in the newest theory, they came in alkylating as well as intercalating, because the rest of the group have in between the DNA bases by intercalating. Now here they use for this cancer, that cancer, this cancer, that cancer. No, they are from occlusion. Like they are used for carcinoma, stomach, colon, breast, pancreas, bladder, neck. This one, no. This is only for pharmacology.
So my injector circulates between DNA bases.
DNA bases. Now I know about this plant. Just in our masjid, in front of our masjid, they have pink Christian plant. They are called as
Anti-cancer.
anti-cancer. Catharanthus roseus. They have two plants. One had pink flower, another have white flower. One plant I have seen in the Mam, King Fahd, Malik Masjid, in Siko area. In Siko area, they have a lot of plant. When I see the plant now, really I love too much the plant because I know they have this chemical constituent. They have this activity. Also have one plant in here, in front of our masjid. One is basil. You know basil? In Arabic, I
Yes.
think they are called as
Basil.
ريحان مش
ريحان. Okay.
because yesterday I talked to Dr. Mastur about this plant. Now we are going to do research on this plant. They have a lot of chemical constituent. They have a lot of chemical constituent. They are used for a lot of diseases, especially they are used for treatment of cough. This leaf, take 2 leaf, add tea, tea, coffee, and just drink. Very good source. I am using this plant from last 2 days, but have the relief, alhamdulillah. Now see this plant. They have chemical constituents. This one, vinclystine and vinblastine. Vinclystine and vinblastine, they have the anti-cancer activity. Now question is that, how they have anti-cancer activities? These chemical constituents undergoes a lot of process and they form oxyradical and hydroxy radical. They form oxyradical, steady oxyradical. Superoxide.
Oh, superoxide.
Steady superoxide.
Yes.
Oxyradical and hydroxyradical. And they cut the DNA.
Yes.
The scissoring the DNA. But please don't memorize the source of this plant. They are obtained from Catharanthus roseus, I don't know. But in pharmacognosy, you must know the source. With Dr. Rizwan.
Yes.
Dr. Rizwan. Because he will ask what is the source of this plant. But I will not ask what is the source of this plant. I will ask how they have mode of action, the formation of oxyradical or superoxide. You know superoxide?
Yes.
All of the above.
Yeah.
Doctor, what is VW?
Van der Waals bond.
Oh,
I mean,
And this medicine, if we take it, it will bring superoxide and hydroxy. But how that these ions will go just for the cancerous cells?
again the last type of question. Last day again they ask the same questions like drug target.
This
Drug target.
also will have. Another plant in Dr. Rizwan. Photophyllum peltatum, photophyllum immodi. I don't know source. Same mode of
أول
action.
مرة نسمعهم.
No, please don't memorize me, sir. In my classes, don't memorize this one.
Okay.
But in Rizwan, you know what is the source of this compound. Photophyllum peltatum, photophyllum
فلتتم.
immodi.
Oh.
Immodi. They have photophylloctoxin. They have photophylloctoxin. They have the same mode of action. Oxyradical, hydroxyradical, and superoxide.
Don't write Doctor oxyradical, hydroxyradical.
Huh?
And down.
Here. Where?
Oh, so cut chain. Oh, okay. Chain cutter.
Yeah, check it. See that.
Okay. So,
And-
Doctor, every chain cutter, it's hydroxy.
Doctor, but they don't have nitrogen.
Don't have nitrogen, but they have oxygen.
Yesterday you said they must have.
In case of videomycin,
And here because of oxygen.
because of oxygen, superoxide.
There will be ferric.
Now see here. This is the natural compound. This is the synthetic compound. This is the natural compound. This is the synthetic compound. Both are the same.
Yes.
Both are the same. Here, add one glucose molecule. You know glucose?
Yes.
And now becomes here ethyl linkage. You know ethyl?
Yes.
Like here, ROH. just heat, what they form? RO
Oh,
by the process of dehydration.
oh.
But if you add here in this process, you add water, what is the formation? Alcohol.
Okay.
Alcohol.
Maybe, doctor, you ask this question how to convert from this drug to this drug.
Wait. I'm coming. I will ask you, like suppose that here, see, like please don't forget metabolic pathway, because every compound, if you're taking, they undergoes metabolic pathway. Metabolic pathway. They are formation of oxygen, hydroxide, and superoxide. They are the mode of actions. Now give me the answer here, honey. Don't anyone. Can this compound undergoes hydrolysis?
Yes.
Where?
An ether.
Very good. Very good. Give the answer, mashallah. Don't laugh, please. You know, English. Can they undergo O-demethylation?
Said no.
No, you. O-demethylation.
Yes.
Same.
Two.
Very good. It means we know if the compound have ester linkage, if the compound have ether linkage, if the compound have amide linkage, they undergoes hydrolysis. I did not. Metabolic pathway.
Oh, yes.
Metabolic pathway. This one, my dear, please. See here. If the compound have,
أول واحدة هيدروسيس الثانية شنو؟
if the compound have
Yes.
ester,
Ester.
if the compound have,
Amine.
if the compound have,
Ether. Hydrolysis.
they undergo hydrolysis. But this compound has two processes.
Yes. Hydrolysis and hydroxy.
Trialkylation.
O-demethylation.
OT.
Our O-dealkylation. This is the metabolic pathway. Oh, please. Like suppose that this is the anti-cancer topic. Not anti-cancer topic, sorry. DNA acts the drug target. Maybe I will not ask what is the mode of action of this one. I will ask what is the metabolic pathway. Because every drug undergoes metabolic pathway.
No.
Please don't forget metabolic pathway.
Hydrolysis and
Here you know, here we know O-demethylation, O-demethylation, O-demethylation. Hydrolysis,
Yes,
hydrolysis, 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 hydrolysis.
Decarbo aromatic, maybe.
Huh?
Carbo aromatic.
Aromatic carbon oxidation.
Yes, there's.
Now second questions. They may be little bit tough. Again to honey. Honey, can this compound undergo benzylic carbon oxidation?
Yes.
Where?
In
No, please come fast, very fast. 1 minute because we have no time. Benzylic carbon oxidation. And now, if he will give answer, I will give 0.5 marks. Come, give 0.5 marks.
Okay.
In final.
Okay. For what?
If you give the answer. 5 marks. Our 1 marks.
What's your question?
My question is, can this compound undergoes benzylic carbon oxidation?
Oh, okay. لحظة يا شباب لحظة الله يحفظكم. Maybe I think this.
Why?
Why? Because this aromatic and this benzyl that that carbon bind to this.
خلاص خذنا
Give the answer. 100% right. 100% right.
خمسة.
No, no, I got it 0.5. I told you just, I told 0.5.
No, you didn't.
0.5. See, very right, very right. Because this carbon have hydrogen.
Yeah.
This carbon have hydrogen. Benzylic carbon. Please, metabolic pathway, don't forget. And second thing is that here. Second thing is that here. Second thing is that here. No, they are very easy. Hydrolysis, 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 hydrolysis.
Hydrolysis.
Aromatic carbon, aromatic carbon. Benzylic carbon, benzylic carbon. Yeah, that's finished. That finished. Nothing is there.
Where did they come?
Yeah.
Yeah. and down.
Here.
Yes.
Both have hydrogen.
Doctor, please go up, please.
Yes.
The same compound.
Same.
Please. No. Yes, up. The same carbon that I chose. Maybe it's 2 benzylic carbon. In the same carbon.
Here.
Yes.
This one.
From this to from this.
Yeah. Yeah. Yes. Now see here, paclitaxel and doxytaxel. They are obtained from this plant in South Africa. In South Africa, but don't know the what is called a source of the plant. Again, they have the same mode of action. Same mode of action: superoxide, oxyradical, and hydroxyradical. Same mode of actions. They cut the DNA like chain cutters, like chain cutter or scissor, or scissoring. This plant again I have seen. This plant again I have seen not here in Al-Khobar, in one hotel. They are called as Marhaba Hotel, Marhaba Restaurant.
Marhaba student.
Marhaba Restaurant. This is one Pakistanis guys. They have this plant. They have the restaurant.
Oh, restaurant.
Because my sound is not clear today.
No, it's
But
not.
Alhamdulillah, I'm teaching Alhamdulillah too.
الحمد لله الله يمن عليك الصحة والعافية ادعوا لي يا شباب.
See, this is the one plant. Again, they have this chemical constituent. See, this chemical constituent. They are called as camptothecin. Now they have anti-cancer activity. They have ring A, B, C, D. But about this natural cells compound have little bit SAR. SAR is very, very important. SAR means not Saudi structure activity
Relationship.
Structure activity relationship. Like suppose that here ring A and B, C and D. See here. Ring A to D are essential for
Activity.
activity. We cannot change from here into anything.
Yes.
But again, if you do substitution here, the activity of the compound is increases.
Yes.
Here, any substitution, more binding. Now here have two groups. One is ethylene dioxide. Here I put in bracket M. It means sometimes it becomes methylene dioxide, and sometimes ethylene dioxide. What is methylene dioxide? Like here O CH2. This is called as methylene dioxide. Methylene means how many carbon?
2, 1.
1. Ethylene dioxide.
2 carbon.
Same thing. Undergo the hydrolysis process, they form hydroxy radical. If they are not no hydrolysis, they become superoxide, oxyradical. You know oxyradical, superoxide, and finally they have the same mode of actions. But again, in the new book, Graham and Patrick, I think 7th editions, they have 2 mode of actions. They have one is superoxide, other by intercalating. You know, this plant raw material given 2 groups of animals. One group of animals is this one, another group of animals is this. I mean 2 groups. Here have 6 animals, here have 6 animals. It was found that in one animal they have A, B, C ring, have intercalating. But another group of animals, it was found that they have D and E intercalating.
But 2 separate, not 3.
Yeah. 2?
Yes, D and E, 2.
Yes.
We said 3.
Yeah, see, all have the one very big structure, but what is the reason, how they break from here, they are not clear. If you break from here, then the E ring will separate, na?
Yes.
Otherwise, how it separate?
Yes.
No separation. If you break here, then A, B, C will separate, na? Then how it separate? They are not written in the clear book, that's why. But again, they have oxyradical as well as intercalating agent by A, B, C ring or by D and E ring. D and E ring. Now see here, little bit. Here, saturation of B ring this pairing. Like suppose that double bond change to single bond, then the activity of the compound is
Increase. Increase.
what is it?
Oh, decrease.
Decrease. Now see here, C and D ring, modification at any modification, any change in C and D ring, then the activity of the compound is
Loss. Decrease.
decreases, yani lost the activity. You know what is this one? What is this one?
Aromatic.
What is this one? Benzene. What is this one?
Pyrimidine.
Pyridine.
Pyridine.
What is this one?
Hydroxypyridine.
Hydroxypyridine or pyridol. Pyridol. Alcohol. You know alcohol?
Yes.
But what is this one?
Acetopyridine.
Pyraldehyde.
Pyridine.
But what is this one?
Ketal.
You know ketone.
Yes.
Pyridone.
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 That's why before that I given some background. Some background. Pyridone ring is essential for activity. Yani we cannot change pyridone to anyone. Now see here, this compound has ketonic group. This is a drug. Here the receptor have ketonic group. They binds with one interaction. What type of interaction is called as? Dipole interaction.
Hydrogen bond. Oh, sorry.
Dipole interaction. Dipole.
ممكن احنا ايوه في ويا دكتور محمد جمعه قال بان الدايبول هنا نفس الهيدروجين بوند.
What's the difference between hydrogen bond and dipole?
حتى قاموا سالوه في الجروب ما ادري كان يا
Hydrogen bond is the bond between
ايوه ما هدي
you know partial negative like sulfur, oxygen and nitrogen with hydrogen. You know electronegative atom?
Yes.
More electronegative atom and less electronegative atom.
Yes.
This is the hydrogen bond. A dipole moment is that this one. Like suppose that this is the ketone group. They have more electronegative, they have less electronegative. This bond will shift from here now up now too much. Because bond electron, they are high electronegative, they are less electronegative. Now here, because this is the notification of dipole moment. This is the notification of dipole moment. Now here is the receptor. They have the ketonic group again. They have the dipole moment. Dipole moment of the drug, dipole moment of the receptor binds to each other.
Dipole. Okay.
اللي كنا نحدد فيها بولر ولا بولر ونحدد اسم البيت.
This is called as but
دكتور if ketone okay it's react with the hydroxy group there is what type of bond
hydroxy group yani OH group.
OH.
See here.
There is dipole and this hydrogen so when react with each other what the bond will be.
After I discuss that with you. Iron dipole I discuss. I discuss with you iron dipole.
Yes.
Iron dipole or dipole iron. I discuss or not?
I was
Absent
yes.
from that class. I know. I discuss iron dipole. Now come on here. See, this oxygen is important for activity. This oxygen is important for activity because they form superoxide or oxyradical or hydroxyradical. Now see here, second question is here, can this compound undergo hydrolysis?
Yes.
Ketonic group. Can this compound undergo benzylic carbon oxidation?
Yes.
Where?
No.
In R.
If the CH3. Yes. Yeah, I like the CH3. Just right.
Doesn't have Dr. H.
If the have H, if have here H, then now see, this is the aromatic part. Here is the carbon.
Also.
Here is the carbon. Here of hydrogen. Here of hydrogen. See.
Yes.
But I mean, doctor, about R, the left side.
Here.
If there is CH3,
Here.
it is not benzylic carbon.
Here. Benzylic carbon.
No, because it doesn't have H.
CH3 3 اتش عندها.
Oh, okay.
Yeah. This same plant I have seen in Sequoia in the same Massi.
Here?
King Fahd,
Okay.
Malik Massi. Very big Massi. The same plant I have given. And second thing, you know Dr. Amir?
I mean, Ali?
Dr. Amir here.
حق اللاب.
Pharmacology. He did PhD in this plant.
عنده PhD.
PhD.
Oh.
In this
حق
plant.
اللاب.
And they have anti-cancer
هذا اللي
activity.
يجيكم.
They have
Anti-cancer.
Amir is my 1 year junior. Amir and Dr. Niaz. You know Dr. Niaz?
Yes.
He is my 1 class junior. Both.
Your
See.
student,
No.
they are.
Fahim is my student.
Really? شوف انا اسئله.
When I was 25th year or 26th year, I did my PhD, complete my PhD. My PhD complete 12 years before.
What's your age now?
Now 38.5.
Still young, doctor.
العمر كله ان شاء الله.
But I have a lot of
دكتور فهيم, your student.
my student.
Really?
He was my student.
So young.
Fahim is my student.
Nice.
How he was in medicinal chemistry?
Very good students or?
I was in PG course, master's course, and Fahim was in first year.
Oh.
Oh.
He was very good student.
Really?
Yeah, really. Come on here. Come on here. They have the ketonic group. This drug have the ketonic group. Now here have OCH3, 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 OCH3. All they undergo hydrolysis or O-dealkylation. Hydrolysis, O-dealkylation. Hydrolysis, O-dealkylation. Hydrolysis as well as
D-amino. D.
And now here I have N.
And dealkylation.
N-dealkylation as well as
Hydrolysis. No.
عندي oxidation.
N.
Deamination. Deamination.
N-hydroxylation.
Hydroxylation.
This is the right. N-hydroxylation.
Hydroxylation.
Because they are N is secondary in nature.
Hydroxylation.
Secondary in nature. Very good. This is the metabolic pathway. Metabolic pathway, Saeed, I will give the metabolic pathway question because they will increase your marks. They are very easy. N-hydroxylations, M-dealkylations, O-dealkylations, hydrolysis. But please, you know,
Easy.
they are easy.
Easy, but when you got doctor question all of these are these. يفلت أمره. حتى لو سهل صعب.
Now, we start another subtopic of the DNA etc. target is alkylating acids. Alkylate, we finish intercalating. Now we start alkylating. Alkylating. Now see alkylating. This is the classification of alkylating agents. This one, this one, this one. All are the classification. Now we start one by one. This one, nitrogen mustard. And behind that have some history. How they have anti-cancer activity. See here, nitrogen mustard. Due to presence of this sulfur, you know, sulfur is high lipophilic character, hydrophobic character. That's why they have very bad side effect. But again, they have very fast acting. They are very fast acting because they are very fast cross the cell membrane. Because cell membrane is lipophilic in character, and also the some amount of the drug will enter into the brain, blood-brain barrier. Because blood-brain barrier is the lipophilic. That's why they have the side effect. Now see here, Due to sulfate, they are called as mustard gas. Now, see here, they causes this type of side effect. Now, note, what is the note? Mustard gas was very poisonous. Why? Because of sulfur. Then what should you do? So, could not be used therapeutically. Then what should you do? Because we think something. We want to replace. Yes.
Yes, I just said.
To
By
avoid
ISST.
such problems, a lot of nitrogen mustards were synthesized and tested as anti-cancer activity. In this case, see here. See here, NH. They replaced by NH by C, NH. Now, how they discover as they have anti-cancer activity? The discovery of anti-cancer activity of this compound by accidentally. I want to discuss one history behind that. See here, like suppose that, give me this bottle. They have the one can. They have one can, they fill with mustard gas or nitrogen mustard. They fill with, now this can, you know boat
Yes.
or ship, you know ship or boat, they, you know sea, Red Sea, Arabian Sea, all the sea. They're carrying this boat, this can have this chemical. And they went to Italy, on the Italy island. They went to Italy Iceland to kill. Why they went to there? To kill human people in World War Second. In World War Second, some persons here have 4,000 people was traveling in this boat, and they have 100 tons of this chemical, and they went to Italy to kill the human people. But in the way, this lids open. When they open, the air will winter. When the air will winter, this SO2 sulfur into SO2 gas. When they becomes SO2 gas, what happens? They get explode. When they get explode, how many person was inside? 4,000 people. In this case, all are die. All are die, but 8 people was survive. Then some people go there, ask, why you survive and how all are dying? Then this person is told, before that I was one problem. Because my here, some cell growth will happen. Some here, some here, some here. But when this accident will happen, this was treated.
عارف سرطان عندك عنده سرطان.
سرطان.
ايه. اورام يقول لك تيومر زين دكتور.
A tumor. This tumor was treated. By this way, the discovery of this gas was accidental. I written because if you read the book now, very clear. See here, during World War II, a ship carrying. See here, please. See here, during World War II, a ship carrying 100 tons of mustard gas explode during an air oxidation in the harbor of Bali. The name of the island is Bali in the Italy. Then what happens? 1,000 people died because of poison of. But some people suffer from leukopenia or blood cancers or the tumor in their head and the neck, had or have treated by this accident. By this way, and by this way, and by this accident activity, anti-cancer activity of mustard gas was discovered. This is the discovery of anti-cancer activity of this compound by accidentally. But now we go to scientifically. Yes.
Doctor, people who died dead for the poisonous activity, the poisonous effect, or due to explosion? Due to explosion.
Due to explosion, the
And-
normal DNA cells get disturbed.
Due to the poison.
This is poisonous.
Uh-huh.
Now, see the scientifically. Now, they are the layman. Now, come on scientifically. How they have? Just only for 5 minutes, then I will leave. Just only for 5 minutes, don't worry. See, when this drug will take, because you know our body temperature, sorry, physiological pH is 6.2 to 6.4. See, all alkylating agents, when they enter into the body cells, they converted into highly reactive aziridinium. What is the aziridine? Aziridinium means they have electron deficient. Yani they have positive center. Yani if they have positive center, can they say as cation?
For yes.
Can they say as electrophile?
Yes. Bind to DNA.
Phosphate.
Yes.
Carbonium ion.
See. Now you understand, na?
Yeah.
Very good. All kinds of converting to aziridinium ion, which acts as electrophiles, which then attack with the nucleophilic center of,
Phosphate.
like maybe phosphate, maybe carboxylate, maybe hydroxide, because they have nucleophilic. When they bind, what happens? The overall process is.
Alkylation.
Now see one example, because we understand from example. See example.
Yes.
See here. This is your drug, na? Nitrogen mustard and CH2, CH2Cl and CH2Cl. Here in the nitrogen mustard was hydrogen, but we replaced by CH3. How you replace? If they were hydrogen reacts with CH3Cl, loss of HCl becomes CH3 by alkylation, alkylating group. This is another process. Now see here. Now what happens? This is the more negative. This is the less negative. They become negative. They becomes. Now they get lost. This positive nitrogen has the lone pair. Positive negative bind for aziridine.
Intermolecular interaction.
Intermolecular interaction. Aziridine, they have positive charge. This positive charge attracts to the nucleophilic center of DNA. Now, see, this is the nitrogen mustard or mustard, and this is the aziridinium ion. Acts as electrophilic or cation or carbonium ion or electron deficient center. You can say anything. All of the above. Carbonium ion, carbocation, cation, electrophile, electron deficient center. We can say anything. This is the nucleophile. You can say anion, carbon ion, electron this center, nucleophilic center. You can say anything. Now both are attract. How they attract? Now question is that on the DNA basis, where is the nucleophilic center? See the base. Adenine, guanine, cytosine. After that, you know thymine.
Yes.
You know uracil.
Yeah.
This is called as purine.
Yes.
9 membered. Here cytosine, thymine, uracil,
Pyrimidine.
and pyrimidine.
Pyrimidine.
Pyrimidine is 6 member.
Yes.
Why they are 6 member? 1, 2, 3, 4, 5, 6. Why they are called 9 member?
Pyridine.
9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Getting my point?
Yes.
They have nitrogen. All nitrogen have
Lone pair.
lone pair. If they have lone pair, can you say nucleophilic center?
Yeah.
Yes.
Can you say anion?
Yes.
Can you say carbon ion?
Yes.
Can you say electron rich center?
Yes.
Yes. Now, these electrophiles attract to nucleophilic center. See here. See here. See here. See here. This is the DNA. DNA. This is the base. Purine, pyrimidine, adenine, guanine, cytosine, thymine. Have you know?
Yes.
Now they have the nucleophilic center. This is your medicine. These are your medicines. And CH3, CH2, CH2, Cl, CH2, CH2, Cl. By the process of form azidinium ion, just I discussed. They access electrophiles. This electrophile attack to Cl. The ring will open. Again, here have chlorine, here have carbon, more electronegative, less electronegative. They get lost. What happens here?
Positive.
They have electrophile again. Another DNA chain. In between the DNA chain, this drug will enter.
Correct.
Have no enter or no?
Yes, yes.
Form a complex. After that, DNA fluorescence will be. Now leave it here. Understand or no?
Yes.
Please don't study pharmacology from here. You study chemistry. Now I am tired. Please leave it here. Next class.